We are Microchems Experiments, going to present you a complete procedure for determination of sodium and table salt. Welcome to the Microchems Experiments. Be with us, be a scientist. This procedure involves 4 steps. Standard preparation, sample preparation, analysis in AAS and calculation. To conduct the test we need a balance machine, micropipette, atomic absorption spectrometer and volumetric flask. We also need nitric acid, sodium standard and DI water. Let's begin with the standard preparation. Before going for the standard preparation we need to prepare diluent first. We will use 1 normal nitric acid to prepare sodium standards. 1 normal nitric acid can be prepared by diluting 69.75 ml nitric acid into 800 ml deionized water first, and after cooling make a final volume of 1 liter by adding deionized water. Now we will prepare 0.1 ppm sodium standard. Take 80 ml of diluent into a 100 ml volumetric flask. Add 10 microliter sodium standard of 1000 ppm. Add enough diluent to make the final volume of 100 ml. 0.25 ppm sodium standard can be prepared in the same way, except 25 microliter sodium standard of 1000 ppm is added instead of 0.1 microliter. 0.5 ppm sodium standard can also be prepared in the same way, except 50 microliter sodium standard of 1000 ppm is added instead of 0.1 or 0.25 microliter. Our standards are ready to use. For detailed about standard preparation, take a look at our video for standard preparation. Link is given in the description section of this video. In this step we will prepare our table salt sample. Gather everything needed for sample preparation. Wash all of the flask with deionized water. Label first volumetric flask with sample 1 dilution 1. Label second flask with sample 1 dilution 2. And label third flask with sample blank. Take weight of 6 mg of salt sample and transfer into first volumetric flask of 100 ml. Fill the flask with deionized water up to the mark, washing the weighting paper. Shake well to dissolve the salt with water completely. First dilution of the sample is ready. Now take approximately 80 ml of deionized water into the second flask. and add 1 milliliter sample solution from the first dilution flask by micropipette. Fill the second flask with deionized water up to the mark. Second dilution is now ready. Fill the third flask with deionized water, which will be used as sample blank. Mark all the dilution factors on the dilution flask. Our sample preparation is done. Now we will analyze the prepared sample in AAS. Open the software connected with AAS. Close the previous test results and create a new result format. Turn on the sodium lamp. Now load a sodium method from the library. If no method is available, then create a new method for sodium test. Go to the calibration section and put the standard values. In this test we will use 3 standards, 0.1 milligrams per kilograms, 0.25 milligrams per kilograms, and 0.5 milligrams per kilograms. Put the lowest value first, then put 0.25 in the next row, and put 0.5 in the last. Review all other options of the method settings. Click OK to finalize the method. Click on Setup Optic icon and keep the nebulizer free, allowing the intake of air from the environment. This option will set the sodium lamp automatically. Turn on the gas, air pump and fume hood. Now turn on the burner. Put the nebulizer into the diluent that we used for standard preparation. Click on Auto Zero. This option will minimize the absorbance of the diluent. Click on Analyze icon and set the analysis name. And click on Analyze option. The instrument is asking for air. Keep the nebulizer into the diluent and click on OK. Now the instrument is asking for blank or diluent. Keep the nebulizer unchanged. The instrument is measuring the absorbance of diluent. Now the instrument is asking for 0.1 ppm sodium standard. Shake the standard flask. Dry the nebulizer and replace the blank with 0.1 ppm sodium standard. Click on OK. The instrument is measuring the absorbance of 0.1 ppm standard. The instrument is asking for 0.25 ppm sodium standard. Shake the standard flask. Dry the nebulizer and replace the 0.1 ppm standard with 0.25 ppm sodium standard. Click OK. The instrument is measuring the absorbance of 0.25 ppm standard. Now the instrument is asking for 0.5 ppm sodium standard. Dry the nebulizer. Shake the standard flask and replace the 0.25 ppm standard with 0.5 ppm sodium standard. Click OK. The instrument is measuring the absorbance of 0.5 ppm standard. Our standard curve is fitted successfully. Now run diluent or blank through the nebulizer to clear the standard residues from the channel. Remove the blank. Dry the nebulizer and insert it in sample 1 dilution 1. Click on Measure Sample. Rename the sample ID and click OK. The instrument is measuring the absorbance of dilution 1. A warning dialog box is appeared which tells us the sample contain high concentration of sodium than any of the standard used to make the standard curve. This means we need to place more diluted sample to get the accurate result. Run the diluent or blank to clean the nebulizer channel, removing residues of previous sample solution. Dry the nebulizer and insert it into the dilution 2 solution. Rename the sample ID and click OK. The instrument is measuring the absorbance of dilution 2 sample solution. We found that the sodium concentration in dilution 2 is 0.2383 mg per kilograms. This is the acceptable result because it falls between our standard curve. So we will use this result in the calculation to find the sodium content in sample 1. Now replace the flask with sample blank. Rename sample ID as sample blank and click OK. The instrument is measuring the absorbance of sample blank. The instrument found that the absorbance of sample blank is less than the blank absorbance, which is irrelevant. This is why we will not consider the sample blank reading in the calculation. Remove the sample blank and turn off the burner. Save and print the test report. Now we have to calculate the concentration of sodium in the sample. Report page 1 represents different information about the test and instrument. Report page 2 represents different information about the method and instrument. Report page 3 represents the calibration curve and absorbance and results of samples in blank. First of all, we will align some values in the right side of the board. We took 6 mg of sample for testing, that is why weight of sample was 6 mg. In gram we can write the sample weight is 0.006 grams. We got the concentration of sodium in sample 1 dilution 2 from the AAS analysis, which is 0.2383 ppm. We can find the dilution factor of dilution 1 by dividing the total volume of the dilution 1 solution by the sample weight. We make 100 milliliters volume. And we used 0.006 grams of sample. We can find the dilution factor of dilution 2 by this formula. Dilution factor 1. Multiplication sign. We made 100 milliliters volume in second dilution. And we transferred 1 milliliter solution from the dilution 1 to make the dilution 2. By solving this equation we get the dF2 is 1,666,666.67. Now we can find the sodium content in sample by multiplying C sodium, which is 0.2383 by dF2, which is 1,666,666.67. By solving the equation we get the sodium content in sample is 397,166.67 ppm. We can find the percentage value of sodium by simply dividing the ppm value of sodium by 10,000. which is 39.71%. So the sodium content of our tested sample is 39.71%. Have a good day and good night.